So in this session, we will discuss about the thermal expansion. What is the meaning of thermal expansion? When we supply heat energy, the substance will change its length, shape or size. We call that as a thermal expansion. And thermal expansion can occur. So simple definition of a thermal expansion: when substance is heated, it changes its shape, size or length, and this change in the shape or increase in the shape, size or length, what we call that? We call that as thermal expansion. Example, if we have equal volume of solid, liquid, that must be inside a container, and the gas. So we have three states: solid, liquid and gas, and they all have the same volume. Like the volume of solid is same as volume of liquid, and the volume of a liquid is same as volume of the gas inside the container. And we supply equal amount of energy. We heat them and we supply equal amount of energy. Like if I say I supply 1000 joules to solid, then we supply 1000 joules to liquid, and then we supply 1000 joules to gas. So we have solid, liquid and gas. We supply equal amount of energy to these three states of the matter. Which one you think will expand the most? Is it solid, liquid or gas? Which state expands the most? When we compare the thermal expansion, we supply heat energy to equal amount of solid, liquid and gas. Which one you think expands the most? So the one which expands the most, the correct answer is gas. Gases expand more than liquid and liquid expand more than solid. What is the reason for that? Because the particle arrangement of the particle in solid, the particles are tightly packed together and they have a strong attraction. There is a strong attraction between the particle, so particles can move but not too far away from each other. That's why liquid expands, the solid expands the least. What about liquid? In case of liquid, particles can move past each other. So as the particle can move past each other, and compared to the solid, they have weak forces. That's why when we supply the energy, the particles can relatively move further away as compared to that of solid. And what about the gas? Like example, because in the gas the particles are far away from each other, and the force of attraction, the force which is keeping the gas molecules together, is very weak. So when we supply energy, these gas molecules can easily move away from each other. That's why the gases expand the most. So which substance expands the most? So gases expand more than liquid and solid. Is it clear why the thermal expansion or expansion of a gases is greater as compared to that of liquid and solid? Because in gases the particles have weak attraction, whereas in liquid and solid the attraction is relatively higher. And when we have two metals, even when we have two metals together, when one metal is connected with another metal, so even if two solids are there, solids have different rate of expansion. One will expand more, the other one will expand less, because even within the solid, the type of the size of the particle is different and attraction of the particle is different. So when we have two solids together, two solid pieces together, we call that as a bi. The term bi means two, metallic, because metals are there, strip. So this is refer when two metals are connected with each other, that strip is known as bimetallic strip. It's easy to remember because the term bi refers to two. Like you say bicycle, that means that it is having two wheels. So bimetallic strip means a strip which consists of two metals. So when we supply equal amount of energy, like example, if I supply 100 joules of energy to each metal, even when both are metals, both will have a smaller expansion compared to that of liquid or gas. But even when two metals are there, they have a different expansion rate. One expand more, another one expand less. So how the strip will change, the length or the size of the strip will change according to the expansion of the two metals. So as you can see here, this is a bimetallic strip. So when we place over the burner, we observe that the strip bend. So top side was place a brass and bottom we place iron. Which one you think is expanding more? The strip is bended towards the iron. So which one you think is expanding more? Is it brass or iron? By looking at the figure of the bimetallic strip here. So which one size increase more? So when you compare the length, you will find brass expand more. So whenever, yeah, that's right, the brass expand more. So the metal which expand more, it will bend, the strip will bend because of that metal. If iron expand more, then the strip will bend upward, the side of the brass. But because brass expand more, so the strip is bending down. So this is a table which shows the expansion of different substances. Invar is there, some of them are alloys, some of them are glasses, type of the glasses, and some of them are pure metal. Like example, aluminium, for every, if we have a 1 meter long piece of aluminium, when we supply heat energy and increase the temperature by 100, its length or size will increase by 3 millimeter. For brass, it will increase by 2 millimeter. Steel is 1 millimeter, concrete 1 millimeter, glass 0.9, platinum alloy 0.9, glass, perfect glass is 0.3, and invar is there, which is also an alloy. It's about 0.1. You don't have to memorize these values, just to understand the concept. That example, if I use invar and I use aluminium, the bimetallic strip consists of invar and aluminium, and we supply equal amount of heat energy, where it will bend, upward or downward. The side of invar, as you can see, aluminium expand more as from the table, and invar expand the least. So which side the strip will bend, upward or downward? So because aluminium expanding more, expansion of aluminium is more, so in this case it will bend upward. So always the bimetallic strip bend on the towards the side, towards the metal or an alloy which is expanding less. So what are the uses of these bimetallic strip? The bimetallic strip can be used in fire alarms. How it can be used in fire alarms? So we have invar and brass. We know brass expand more and invar expand less. So how a bimetallic strip is used in a fire alarm? So in case of fire, when it's fire, the temperature will increase for that region. So when the temperature increases, temperature rise. So we have brass and we have invar. We know brass expand more and invar expand less. So which side it will bend? Right hand side or left hand side? The brass expand more. One side we have a brass and the other side we have invar. And from the table, you don't have to memorize that table in exam, that will be given if they're asking any question related to that. So in this case, we know invar expand less, so it will bend towards right hand side. So when the strip will bend towards the right hand side, so what happen, as it bend, it will come in contact, the strip will come in contact, and when it will come in contact, the current start to flow in the circuit and the bell will ring. So as this bell will ring, we can identify that there is an increase in temperature or there is a fire in the premises. So, and what will happen once the temperature decrease, like when we put off the fire, if there is no source of the increase in temperature, and when we put off the fire, so the strip will by itself, it will, because due to fire it expand and it bend, and when it cool down, it will return back to the same position, and as it return back to the same position, the circuit is not complete. As the electricity circuit is not complete, the alarm will be off. So in case of fire, it will work, and if there is no fire, if it's a normal temperature, then it will return back to the same starting position and the bell will be off. Is it clear? The working of a fire alarm, the application of the bimetallic strip, the two metal strip. Any doubt till this point? Same way, uses of thermal expansion. Liquid in a glass thermometer make use of the thermal expansion. Like example, you have seen the thermometer which we are using, the clinical thermometer or the laboratory thermometer. They also uses a thermal expansion. How a thermometer uses a thermal expansion? So what happen if there is a high temperature or heat is there? So the bulb of a thermometer which is filled with a liquid, that liquid will absorb the heat energy from the surrounding and the liquid will rise, so the level will change. The markings are there on the thermometer, like -10 is there, 0 is there, 10, 20, 30, 40 and so on. So when outside, if the temperature is high, the bulb of a thermometer which is filled with a liquid, and the liquid which we are using here, it can be a mercury or it can be alcohol. So when this liquid expand, the level of the liquid changes in the capillary or the tube. So if high temperature is there, the level will rise more. And what will happen if surrounding, if it cool down, like example, if surrounding we have a low temperature, so this liquid will start to lose the energy to the surrounding, or it will give out the energy to the surrounding. As it give out energy to the surrounding, the liquid will contract. Contract means it return back to, or it reduces the size, or it will return back to the bulb. So expansion and contraction, we can use this in a liquid in a glass thermometer. This is one application of thermal expansion. What else? For example, if there is a metal rod is there and we want to put this washer, but this washer is small. So what we can do, if this metal, if we want to put the washer on the metal, so we can use thermal expansion. What we can do, we can heat this washer. So we supply the heat energy to the washer. The moment we supply the heat energy to the washer, so size of this washer will increase. And once its size increases, we can place over the rod, and when it cool down, it will contract, and as it contract, it will fix on the rod. So we can use the thermal expansion and contraction to join the two parts from to each other. Same way, example, if you find it difficult to open a lid of a jar. So what you can do, you can just place it or use a hot water. So when you place when you place this jar lid in a hot water stream, then what happen? The lid will expand, and as it will expand, so it will be easy to open the lid from this jar. So these are some uses of the thermal expansion. And bimetallic strip, we already discussed that it can be used in fire alarms, thermostats, or thermometers. Is it clear? Some uses of the thermal expansion? Anyone having a doubt or a question? Any question or a doubt till this point? What happened in thermometer? A thermometer consists of a bulb. This is a bulb of a thermometer, and that bulb is connected to a tube which we call capillary. So this is a bulb of a thermometer, and here it's a capillary, also known as bore. Now what happened if it is too hot outside, so more energy is there, that energy is absorbed by the liquid which is present in the bulb. So when this liquid will absorb energy, the liquid will expand. So as the liquid will expand, the liquid rises in the capillary, and on the capillary the numbers are written. Like there are numbers, say -10 is there, 0 is there, 10 is there, 20, 30, 40, 50, and so on. So when outside, if it is too hot, the thermometer bulb, the liquid inside the bulb of a thermometer it will absorb the energy. When it will absorb the energy, the liquid will rise in the capillary, and as this liquid rise in the capillary, we can identify what is the temperature of the surrounding. And if the temperature of a surrounding decreases, so that liquid which was rises, now it start to contract and it return back to the bulb. So rising, like expansion and contraction of a liquid, we use that in a thermometer. Is it clear, this idea about how thermometer uses the thermal expansion? The next part is about the temperature, how we define a temperature. So basically, this is the temperature. It is a degree of hotness or coldness of an object, like how hot or cold the object is. We can find that by knowing its temperature, or by using a device or apparatus which is known as thermometer. So as I mentioned, this is a bulb of a thermometer. This is called a bulb, and that bulb is there inside a glass. Bulb is made up of glass, and then there's a capillary or the tube. So what happened when the thermometer bulb absorbed the heat energy from the surrounding? So as it absorbed the heat energy from the surrounding, the liquid level will rise. And if outside, if it is cold, then the liquid which is there inside the thermometer loses the heat energy to the surrounding. As it loses the heat energy to the surrounding, the temperature will decrease. So rise and fall of the liquid in a thermometer depending on whether the outside, if it is hot, the liquid will expand, the level will rise, and if it is cold, the level of the liquid will decrease as it will contract. Is it clear, the concept of a thermometer? So how we define a temperature? What is the meaning of temperature? Temperature refers to degree of hotness or coldness of an object, like how much object is hot or cold. How we determine this? We determine it by using a temperature. So comparison is done on the basis of temperature, and the unit of temperature, the SI unit is Kelvin, but other common units are Celsius and Fahrenheit. There are different types of thermometer. We can have a liquid in a glass thermometer. We have thermocouple, and we have resistance thermometer as well. So different types of thermometer are there, liquid in a glass thermometer and thermocouple, because this is a part of your syllabus, so you have to learn the working of liquid in a glass thermometer. So how a liquid in a glass thermometer works, and liquid in a glass thermometer is divided into two categories. One is called laboratory thermometer, another one is known as the clinical thermometer. A liquid in a glass thermometer consists of what? Consists of a bulb. This is called a bulb of a thermometer. And here is a capillary, also known as bore. So how it works, again I will repeat because this is an important topic. So what happens if outside, if it is too hot, the bulb, because only part where it can absorb energy directly, that is bulb. So bulb is a region where a thermometer can absorb energy directly. So when it will absorb energy, the bulb of a thermometer is filled with a liquid, and the liquid can be a mercury or alcohol, can be used depending on what is the purpose or what temperature we want to measure. So when this liquid will absorb heat energy, it expand. So as it expand, like example, if outside temperature is say 60 degrees, so original level was 30, but outside it's hot, so the level of the liquid will rises to 60 degrees. If the outside temperature changes to 80 degrees, so what happened? The liquid will further expand and it rises to 80 degrees. But if the outside temperature decreases, so when the outside temperature decreases, like example, if outside the temperature is -2, it's too cold. In that case, the liquid will lose the energy. The liquid which is there inside the bulb of a thermometer will lose its energy to the surrounding, and when it loses its energy to the surrounding, the level, as the liquid contracts, so level of this liquid will change, and it will change to -2 degrees. So expansion and contraction of a liquid depends on the surrounding temperature. If surrounding it's too high temperature, then the level will rise. If surrounding temperature is low, then the level will decrease. Is it clear? And this is a laboratory thermometer. In a laboratory thermometer, this capillary is exact, a cylindrical capillary is used. But what about the clinical thermometer, the thermometer which we are using in our home? That is called a clinical thermometer. First, I will show that thermometer and then compare. In a clinical thermometer, the thermometer which we at the clinic you will find, or even it is there very common at our home. So there is a constriction there. There is a bend in the capillary. What is the reason to have this bend in the capillary? Because what happened? Example, the room temperature. The purpose of the clinical thermometer is to find the body temperature. Example, the room temperature is 20 degrees. Okay, and you are using your clinical thermometer, you work out, you find that your body temperature, an example, your body temperature is 38. But when you place this thermometer outside, like example, in your mouth, you place this thermometer and you record your body temperature, but when you take out from your mouth, now the thermometer is exposed to the surrounding. The clinical thermometer is exposed to the surrounding. So as it is exposed to the surrounding, what will happen? It will show a surrounding temperature. It will return to, the contraction will occur and it will return to the bulb. So to avoid the liquid to return back to the bulb again, what we have a bend in the capillary which we call constriction. So because of this bend, the liquid cannot flow back by itself. It cannot return back by itself. So we have to provide a jerk. That's why you will find whenever a doctor or a nurse using this clinical thermometer, so they provide a jerk to this thermometer before using for another patient. What is the reason for that? Because there's a bend in the capillary, so the liquid can expand, but it cannot return back to the same into the bulb. So to remove the liquid from the capillary so that all the liquid travel to the bulb, we provide a jerk to this clinical thermometer. So main purpose of this constriction is to stop the liquid to return back to the bulb so that we can see our body temperature. Otherwise, if there was no constriction here, if it was exactly straight without a constriction, so what might happen when you take out this bulb, this thermometer into the surrounding, the liquid will contract, and as the liquid will contract, the liquid will return back to the bulb. But because we want to store, we want to make the liquid stop at the point, that's why there's a constriction used in the clinical thermometer. Is it clear the difference between the clinical and the lab thermometer? So lab thermometer does not have any constriction, does not have a bend, but in a clinical thermometer, because we don't want the liquid to return back to the bulb, that's why there's a constriction. So when you're using it again, you have to provide a jerk to this clinical thermometer so that all of the liquid return back to the bulb again. Then these are the features, these are information related to clinical and lab thermometer. The definitions which you have to learn: sensitivity, linearity, and the range of the thermometer. So what is the meaning of sensitivity? The term sensitivity refers to greater expansion of liquid for 1 degree change in temperature, or the greater difference between the 1 degree marking of thermometer. So example, we have two thermometers. Normally we'll talk about laboratory thermometer. Clinical thermometer is just you should be able to distinguish like why there is a constriction there in a clinical thermometer, but not in detail. You have to learn. For the laboratory thermometer, you have to learn in detail. So example, we have two thermometers. A and B. And the marking, the numbers which are written on thermometer A, it is written like example 1, 2, 3, 4, and 5. And the marking on the thermometer B, it is 0, 10, 20, 30, and so on. Which thermometer is more sensitive? The sensitivity means for every 1 degree change in temperature, there is a greater change in the liquid. So which thermometer is having a greater difference between the 1 degree mark? Yeah, what about others? Is it A or B? Which thermometer is more sensitive? Yeah, that's right. A is more sensitive. Why? Because you can clearly see when the temperature change by 1 degree, this is the expansion of, this will be the expansion for A. But when the temperature changes by 1 degree, because 0 and 10 are there, so 1 degree will be somewhat here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So when there is a 1 degree change in the temperature, the thermometer B will have this level. So as you can see, when the liquid changes more for every 1 degree change in temperature, we call that thermometer to be more sensitive. And thermometer B is less sensitive. So sensitivity simply refers to the expansion of the liquid, the one which will have a greater expansion of the liquid for every 1 degree change in temperature, that thermometer is more sensitive. So as you can see in the picture, the two thermometers are shown in the picture. Which thermometer is more sensitive? If I say I have two thermometers, one is A, another one is B. Which thermometer is more sensitive? Which is having a greater difference in the 1 degree mark? Because as you can see, any number you can take, like this is a 1 degree mark for, this is a 1 degree mark for thermometer A, the 1 degree mark for thermometer A, and for thermometer B it's a very small marking is there. So when we compare them, for A there will be a greater difference in the marking, like 1 degree mark, as compared to that of B. That's why A is more sensitive than B. And if you want to make a thermometer, if you want to increase the sensitivity of a thermometer, what we can do, we can use a thin capillary. Like I have this thermometer, and I want to make this thermometer more sensitive. I want to increase the difference between the marking. Like here it is written 1, then 2 is there, 3, 4, 5, and so on. And I want to increase the marking. So if I want to increase the marking, what is one way I can increase the marking or make it more sensitive? Is by using, I keep the same size bulb, I use the same size bulb, but I use a narrow capillary. So when we use the same size bulb, but a narrow capillary, a narrow tube, so what happened? Because a narrow tube expansion, the increase in the length will be more. So this will be 1 degree mark, then there will be 2 degree mark, 3. Because in a narrow capillary, area is smaller, so the change in the height of the liquid will be more. That's why if we want to make our thermometer sensitive, this is one of the way. What we can do, we can narrow the capillary, make a thin capillary. This is one way. What is the second way of making it more sensitive? We can use a large bulb. Here it is written thin bulb. It means it refers to a large bulb. So example, if you have a thermometer and you want to make it sensitive, so there is also a second way to make it sensitive. You keep the capillary same size, but instead of instead of changing the capillary here, you change the bulb. You use a large bulb, because large bulb will have more liquid, and as it will be more liquid inside the bulb, it will have a greater expansion. So these are the ways by which we can increase the sensitivity of our thermometer. One is by using a large bulb, and the second one is using a narrow bore. or a narrow capillary? Is it clear how we can make our thermometer sensitive? So this is using a large bulb instead of thin, it is a large bulb. The second thing is the range of the thermometer. Range means the temperature which our thermometer can read. That's called a range of a thermometer. As you can see, a clinical thermometer, which is shown on the screen, it can read from 35 to 42. So how many numbers this thermometer can read? It can only read 7 degrees, starting from 35 to 42. And how many numbers this clinical thermometer can read? In this example, starting from -10 and to 110. So how many numbers it can read? It can read 120 numbers, like 10, 20, 30, 40, 50. From 0 to 110 is 100, it's 110, and then 10 more numbers are there from 0 to -1. So this thermometer can read 120 numbers, but a clinical thermometer is only able to read only 7 numbers. So which is having a greater range, or which thermometer can record or read more numbers? So that is the laboratory thermometer. So laboratory thermometer or a lab thermometer is having a greater range as compared to that of clinical thermometer. So range is refers to the numbers which our thermometer can read. And if we want to increase the range, what we can use a longer capillary or longer bore. So if we want to make our thermometer read more numbers, we should increase the size of the capillary. So if this is a bulb of a thermometer, and here's a capillary, say it was reading from -110, 0, 10, 20, 30, and so on. I want to increase the range. So if I want to increase the range, what I can do, I can increase the size of the capillary. I use a longer capillary, so my thermometer can record more numbers. So the range of a thermometer increases by increasing the size or the length of the capillary. Is it clear, this part, how we can increase the range of a thermometer? So less than a minute left. I'll share another link and continue this discussion of thermometer.